Hey guys, this is Miss Dupin. Today we're going to talk about alternate angles. So this is a continuation of our transversal unit, and we are first going to go over the definition of alternate interior. So alternate interior angles are inside the parallel lines and on opposite sides of the transversal. So what this looks like in our picture is they are inside the parallel line, so angle 3 is interior, but they are on opposite sides of the transversal, so angle 6 has to be our alternate interior pair. That leaves one other pair, which is angle 4 and angle 5. Next we have alternate exterior. These are outside the parallel lines, but still on opposite sides of the transversal. So to show you a couple more examples, alternate exterior, if we choose angle 1, angle 8 is alternate exterior to that. If we choose angle 2, angle 7 is alternate exterior to that. The special thing about alternate angles is that these angles are congruent to each other. Congruent means that they have the same angle measure, so they are going to be equal to each other. So when we're setting up our equations today, our two angles are going to be set equal to each other instead of adding up to 180 like we have been doing. So for our first example here, we have two angles that are alternate exterior to each other. When I start writing my equation, I like to start with my angle that includes x in it if I have a choice. And I am going to set 5x minus 10 equal to 125. At this point, this is a simple two-step equation where we need to add 10 to both sides, bring down 5x equals 135, and then divide by 5, and this will get us our x. Our x equals 27. Now the great thing about alternate angles is although you can plug 27 in for x and get the answer, your answer should be 125 because your angles are congruent to each other. So the only reason you really need to complete these problems is to be able to find your x, but you should know that your angles, according to alternate angles, are congruent to each other. So for our next example, we have alternate interior angles. So we are going to take these two angles and set them equal to each other. My personal preference is that I take the angle that has the higher x value, which would be this 5x, and put it first in the equation. So 5x minus 54 on one side equals 3x plus 16 on the other side. Now this is a variables on both sides situation where you have all your x's on one side and all your constants on the other side. And by have, I mean you need to get them there. So the first thing we're going to do is move 3x over to the x side of the equation. Then we're going to move 54 over to the constant side of the equation. Then we are going to do the math. So 5x minus 3x is, 2x. And then 16 plus 54 is 70. Then we are going to divide both sides by 2 to solve for x, and we get that x is 35. Now in this situation, we don't know either angle, so we at least have to plug 35 into one of the angles that have x for it. So I'm going to do 3 parentheses 35 plus 16 because that equation just looks a little more friendly. I got 121 degrees. Since this angle is 121 degrees, sorry, this one right here, that means this angle has to be 121 degrees as well. So we're going to do one more example where we have alternate exterior angles, and we are actually using y as a variable this time. So I'm going to change this to y equals instead of x equals. And like I said, I normally like to start with my higher variable, so I'm going to start with 7y minus 55, set that equal to 3y plus 53. Once again, we're trying to get our variables over to one side, and then our constants over to the other side. So I want to subtract 3y over to the other side, and I want to add 55 over to the constant side. Then we do 7y minus 3y, which is 4y, and 53 plus 55, which is 108, and then divide by 4 to get my y. And we get 27. So my y value is 27. At this point, we need to take 27 and plug it in for one of the angles. I'm going to choose 3y plus 53, so 3 parentheses 27 plus 53. And that's going to solve for our angle. Which is 134 degrees. So both angles have to be 134 degrees because they are congruent since they are alternate angles. And that is it, guys. Let me know if you need anything. Bye.